All right. So, as promised, here's Osito. He's biting my arm, just like, a little bear would. Which, if you don't speak Spanish, that's what his name means in Spanish. He's, he doesn't really want to be up here right now because his sister dog is doing something cool. She's eating food, so he wants to go do that. Anyway, I don't think he's going to be much help making this Z score calculator that we're going to be working on, but that's what we're going to be doing. As soon as I set him down. Yeah, I know. Sorry, dude. Here, look at him really quickly. Look. There. Yeah. All right. He doesn't care. Okay. Down you go. Okay. That was like right into the sun. Yeah, that's crazy. Okay. J.J. Abrams is making this video, apparently. So, let me turn off video. There we go. And we can go over to Excel. So one of the things that I'm going to show you how to make is this graph. This is a bonus thing that I didn't show you in class. This is also like a totally advanced thing. If you're good with Excel, you might want this. If you're not good, you don't have to have this. Though I think having this visual representation makes what you're doing a little more obvious, right? So when you have a z-score, you put the information in, and this will actually graph it out, so you can see what you're working with. Okay, let's get started. Also, I'm recording outside, you can tell, so there's a lot of nature noises, like birds and loud neighbors. Yeah, there was one right now. Okay, so what you're gonna need, let's take a look at our formula for a z-score. If you remember what it is, kind of write it down and you'll be able to follow along. If you don't remember what it is, then I've wasted enough time for you to kind of prompt your memory, so I'll just tell you what it is. So z equals, and we're going to have to do this kind of in Excel terms, but x minus, we're going to use a large M to denote mean, just in this case because I can't put an x bar into Excel. So the observation minus the mean over the standard deviation. That's our z-score. And then we can also figure out the percentage of the to the left of that number, percentage of the distribution to the left of that number, and I will show you how to do that in this calculator as well. So what you're going to need is three things, right? You need to know three things, and then you want to know one thing. And what you need to know is let's put in the mean, the standard deviation, and the score itself. And the output is going to be the z equals score. What? Z-score. Yeah, there we go. All right, like always, I like these to be green. And this one to be yellow. All right. So, I don't know, what do we want to put in here? Let's put in 65 as the mean. The standard deviation is, I don't know, 3.5. And the score that we're working with is 68.5. That's one standard deviation up. Yeah, that's one standard deviation up. Okay, so for z-score, it's a pretty easy formula to write. What we're going to start with is an equal sign. We always start with an equal sign. And then we're going to go right into parentheses. The reason we're going right into parentheses is we have this subtraction that we're going to need to do, and it needs to be done first before that phrase is divided by the standard deviation. So we need to set it apart with parentheses. So we're going to do open parentheses, and we're going to subtract our score, which is in C2, from the mean, which is in A2. Now you can close your parentheses because you've got that subtraction out of the way. Then throw in a division sign, and you're going to divide that phrase by the standard deviation, which is in B2. So what you've ended up with here is C2 minus A2 divided by B2, or again the score minus the mean divided by the standard deviation. Let's go ahead and press enter, and we get a 1. That makes sense. We're 1 standard deviation to the right. Okay, that was pretty easy, right? Okay, we have one other thing that we can do with this calculator as well. We can look at percentage to the left. And all we're going to need to do with this is equals, and then we're going to type in one of those interesting Excel, I want to say formulas, it's a command, an interesting Excel command. This one is norm.s.inv. This is a little different than other commands that you've used because it's got, dots in the middle of it and all sorts of things like this. Whoops. Sorry about that. It is not norm.s.inv. That's for something else. It's norm.s.dist. And then you can see that what this wants is a z-score, and then it wants us to say if we're using the cumulative distribution, and we are. So for z, our z-score is in E2. So all we have to do is tell it that here's the z-score in E2. And for cumulative, we have two options, either true or false. True means we are using cumulative distribution function, and false means we're using the probability density function. Well, without going into what we're using here and why, we are using the cumulative distribution function. That's going to give us the amount of the distribution, the percent of the distribution from the left that this score accounts for. So the percentage of the distribution to the left of this score is what this value is going to give us. So we're going to write true. Then we can close parentheses and hit enter. And we've got 84%. Now that makes sense, right? Because within 1 standard deviation of the mean, we've got 68% of our data. And then in addition to that, we've also got everything to the left of those 2 standard deviations, that 1 standard deviation out. So we've got 68% plus all of the left-hand tails. Okay. If you wanted to prove that to yourself, you could figure out the z-score for the percentage to the left of a -1 z-score. Then we'd only be looking at the percentage within 1 standard deviation. So we can do all this again. Why don't we write down 65 is our mean, 3.5 is our standard deviation, and now I have to do mental math to subtract some things. This is 61.5 is our score. We're going to copy the z-score down, and now you see we get a -1 because we're 1 standard deviation to the left of the mean, 1 standard deviation lower than the mean. I'm going to also copy this formula down here, and that tells us that 15.9% of our data is to the left of this score. So if we subtract this from this, we end up with 68%. So 68% of our data is within 1 standard deviation, and that proves would have been telling you with all those fancy diagrams about 68% of our data is within one standard deviation. Okay, so there's your calculator. That's going to give you both the z-score right here and the percentage to the left of that distribution. If you don't want to worry about the graph, you can stop the video now. And if you do want to worry about the graph, well, let's just keep going. Okay, so if you want the graph, the first thing you're going to have to do is build yourself a normal distribution. So we're going to put in a -4, a -3.75. Whoa. -3.75. There we go. And now we don't have to write all the rest of the values in. We can highlight these two and go down here to the fill handle, this little dot where your cursor changes. We're going to drag it, and notice how it goes -3, and then -2.75, and then -2.5. So we've taught it by going from -4 to -3.75 that we want to descend, well actually we want to ascend, we're counting up, by 0.25 in every cell. So we're going to drag this until we get to +4, which is right here. Okay, now this is when you're going to do what I was trying to do earlier, norm.s.inv, and then see how it just says probability. All we need to do is throw this probability in there. Hey, what? Let me double check with something I made earlier. Norm dist, it's so much simpler. All right, apologies. Norm dist. Too few arguments, did I really? Oh, I did. Norm dist needs 4 arguments. So I was trying to make it easier with norm s invert. All right, anyway, sorry. We're going to use norm dist. It requires more arguments and requires a little bit more explanation for each argument, but it's okay. So norm dist, you can see what it wants here is the x value, like the value that we're giving it, the mean of this distribution, the standard deviation of this distribution, and whether we're using the cumulative probability function or not. So the x that we're going to give it is this value in I1. Then we hit comma. Now the mean that we're going to give it is 0. The standard deviation this time is going to be 1. And this time, the cumulative distribution function is not what we're going to use. We want to use something called the probability mass function. Again, I'm not going to go into why that works. What did I do there? I need a 0. I'm not going to go into why that works, but this is what's going to give you the correct graph. So we'll throw that in. And now we have this interesting value here. So go ahead and grab your fill handle and drag this down to cover all of the data that all the numbers that we just put in. That's my neighbor bringing their garbage can home. I knew I should record this outside. Sorry about that. So drag your fill handle down to cover all of this, all these numbers that we just put in. And now we have a whole bunch of numbers. Cool. Well, if we graph these, so go to Insert and click the little arrow next to the scatter plot. And click on the scatter plot here that's just lines. Or don't click on it, just hover over it, actually. You can see that this looks like a normal distribution. Well, that's cool. That's our normal distribution. But we don't yet have our value, so we can see where we are. We're going to add that. So if you did click on it, go ahead and delete that graph. If you didn't click on it, just get off of it like I've done here. So now what you're going to do is scroll all the way down to the bottom of your graph. Now, instead of a number, I want you to leave a space. Leave a totally blank space between the bottom of these numbers and what we're going to do next. Here I want you to put an equal sign, and I want you to go to the z-score in our calculator. You want the z-score, and hit enter. And now the next thing you're going to put in is the exact same cell. You're going to put the z-score in again and hit enter. So here you should have E2, and here you should have E2. And what I want you to put in on the right side next to the top z-score is 0. And what I want you to put in next to the bottom z-score is 0.4. Okay, now I want you to grab both of these strings of numbers, go back to the scatter plot, and click on that line scatter plot, the scatter plot that's just lines and not dots. And there you have a normal distribution with your z-score. One thing that we can get rid of that. We can also get rid of the grid lines. Go away, grid lines. We're going to have to do that somewhere else. Get rid of the title. And we format grid lines to get rid of them. Looks like I have to keep the grid lines for now. All right, well, it doesn't matter. Just how it looks. So what I'm going to do is I'm going to change the z-score. Let's put in a different value for the score. What about 70? And there we go. Our z-score has updated to 1.43, and the graph has shown us that the z-score has moved to the right a little bit. What if we have a score of 50? Well, our z-score is negative 4.29, and the graph shows that I didn't create enough standard deviations in this to accommodate that score. It's a little too low. So let's move it up to 55. Is that enough? Yeah, okay. So that shows us that it's right there. What if we had a score of 66? Well, that's pretty close, and it's right there. So this will move around and show you where on your graph this is. And also another thing that I want you to keep in mind is this percentage to the left is moving right along with this line, right? So we're just a little bit beyond the mean, which would be 50% to the left, and you can see that it's 61. What if we put in a score of 65.5? Even closer. Now we have 56% to the left, just barely over 50, and our line is even closer to the mean. So there you go. There's your z-score calculator and a handy graph that helps you keep everything together in your mind. All right, next is going to be a z-test and then a t-test. Actually, next thing is going to be confidence interval. Then we're going to do a z-test and a t-test. So I'll see you in the next video.